Welcome to this explainer. Today, we're diving into something absolutely wild. We're going to unpack the fascinating mechanisms driving global science right now. Think of it as the ultimate innovation engine, the actual gears and cogs pushing humanity forward. We're talking about everything from breakthrough bioengineering to artificial intelligence and the future of renewable energy. It is an incredibly exciting time to be looking at these global breakthroughs, and the data paints a really vivid picture of exactly where we're heading.
So let's just cut right to the chase with the ultimate question about humanity's rapidly approaching future. Are we on the verge of unconditional abundance or catastrophic system failure? I know, it sounds straight out of a science fiction movie, right? But we are literally standing at this massive crossroad, forced to choose how we manage unprecedented technological power. To figure out how we get to that future, here's our roadmap for today. We'll be looking at the global innovation race, biotech and designing new life, AI as the global superpower, fueling the green energy shift, collaborations and global partnerships, and finally, we'll wrap up with the future of unconditional abundance. Let's jump right in.
All right, part 1, the global innovation race. To really grasp the stakes here, we have to look at how interconnected everything is. Since the 19th century, large, highly competitive teams of specialists have dramatically improved lives all over the globe. But, and this is a big but, this brilliant success and its associated mega systems have proved incredibly fragile. We've built all this amazing prosperity, but it's birthed surprising new challenges that honestly threaten the stability of the biosphere itself. Basically, what worked to get us here won't necessarily keep us safe moving forward.
Because these global systems are so fragile, governments are essentially backed into a corner. They have no choice but to actively build the right environments to attract innovation. What we're seeing right now is a massive global competition. Countries are using tax credits, legal frameworks, and innovation financing just to pull in the brightest minds. In the fight for long-term prosperity, human minds have become the ultimate commodity.
Moving right along to part 2, biotech and designing new life. The whole field of bioengineering is undergoing this massive, dramatic shift. We're moving away from simply analyzing life to actually physically designing it. Traditional analysis-oriented engineering is being completely replaced by design-oriented bioprocesses. Because of this, it's absolutely crucial for practicing engineers to master the molecular basis of life. You can't just be a mechanical engineer anymore. You've got to understand biology at a deep, structural level, or you're going to fall behind.
A really great historical example of this is Bt cotton. Way back in 1996 in North America, this genetically engineered crop was commercialized with built-in insect resistance genes. It used advanced upstream research to solve massive, crippling economic losses from caterpillar infestations. But the real game changer? It created a foundation for far more sustainable pest management systems worldwide. It basically proved that manipulating the biological code could solve macroscopic, real-world problems.
Now, look at how modern nations apply this on a global scale today. Take Dubai. They realized they needed active engagement in new biopharmaceuticals for their 2020 health strategy. But instead of trying to build a massive, wildly expensive infrastructure from scratch, which would have been a totally counterproductive investment, they built a bridge. They deliberately integrated with existing European biopharma hubs like Copenhagen and Gothenburg. It's just a brilliant strategy of ongoing technology transfer rather than isolated, siloed development.
Which brings us to part 3, AI, the global superpower.
When you look at the geopolitical AI race, it's actually highly specialized. It's kind of like a fractured sprint where different nations have totally distinct competitive advantages. For instance, China is identified as the ultimate AI superpower, particularly excelling when it comes to raw talent. Meanwhile, the United States boasts the absolute best business and investment environment, and Japan shows the greatest potential for future policy leadership.
But, beyond the politics of it all, AI is just this incredibly versatile tool. We're seeing it operate across wildly different sectors. It's speeding up COVID-19 drug development, tracking droughts in transboundary river basins, and get this, even conducting forensic analysis of elephant DNA for wildlife conservation. Add in things like mitigating coastal seaweed and managing huge hospital onboarding tasks, and the takeaway is crystal clear. AI is the universal solvent for data-heavy problems.
But, and there's always a but, right? There is a massive catch. AI algorithms are notoriously inscrutable and opaque. You can't always just pop the hood and easily understand the hidden weights or microvariables making the decisions. So addressing ethical biases requires a totally new regulatory approach. Instead of demanding impossible transparency into the machine's inner workings, we have to focus on the evidence, strictly informing users about the input data and the real-world output consequences of these systems.
Okay, part 4, fueling the green energy shift.
Now, this energy shift isn't just about slapping a few solar panels on a roof somewhere. It's formally defined as the fundamental transformation and integration of clean energy into state-of-the-art equipment, using advanced nano, micro, and biotechnologies. We are talking about a complete redesign of operational systems from the ground up, and that demands some seriously advanced knowledge in machine design, control, and materials manufacturing.
And the sheer scale of this challenge, it's honestly staggering. Over 90%, 90, of the physical asset barrier to entering the renewable market lies in the conversion of resources to process fluids and the required materials handling machinery. To put that into perspective, it means the biggest hurdle isn't necessarily capturing the sunlight or the wind, but physically processing, handling, and storing that energy on a massive global scale.
Let's move to part 5, collaborations and global partnerships.
If you trace the history of these international efforts, it's pretty fascinating. Back in 1962, the Apollo space missions basically pioneered Earth observation. Later on, the tragic 1986 Challenger disaster actually ended up spurring the development of critical global data infrastructures. Today, those exact same roots of Cold War space race technology have evolved into amazing collaborative networks like Space for Water, which uses space solutions to combat global water scarcity. It just goes to show how crisis and competition can actually breed the tools for future collaboration.
So, how do we systematically bridge this massive technological divide globally? Well, the proposed solution is a 4-level public-private partnership model. It starts way up top with the global base governing level, then feeds down to regional and multinational levels, then to national public levels, and finally reaches the local level, your R&D labs, universities, and small enterprises. It's a really elegant way to blend top-down macro direction with bottom-up localized problem solving.
And finally, part 6, the future of unconditional abundance.
We are hurtling toward a prediction that is almost unimaginable. Thanks to the exponential advances of AI, biotechnology, molecular nanotechnology, and fusion energy, we're accelerating toward a future of unconditional abundance. Think about that. Production could become so simple and so widespread that it completely erases costs. And without scarcity, the fundamental drivers of human conflict, poverty, crime, and war could literally be eliminated.
But here's the ultimate bottleneck, the real catch to all of this. The technology, it's totally capable of creating this abundance. But our greatest hurdle is the existing structure of wealth and power. The base of power responsible for historical conflicts is going to fiercely resist losing its leverage. It's a massive psychological barrier, wealth paranoia, and the deep fear of losing power. That fear could create extreme resentment and perverse actions as the old systems try desperately to maintain control in a world that just doesn't require scarcity anymore.
Which brings us to a really profound final thought to leave you with. If technology actually solves scarcity, are we truly prepared to surrender our wealth paranoia to embrace an abundant future? As global innovation and the brilliant minds of our engineers build the tools to solve our greatest crises and eliminate scarcity once and for all, is our own human nature, our deeply ingrained wealth paranoia, the final and most fragile system we have to redesign? Really think about what that means for our future. Thanks so much for exploring this incredible landscape of innovation with me today. Stay curious.